Let's just jump right into it. Welcome to this explainer where we're tackling, honestly, the ultimate cosmic mystery. Does our universe actually go on forever, or is there a definitive end to it all? It's one of those topics that just completely breaks the human brain, but in the best possible way. We know the universe kicked off about 14 billion years ago and has been expanding ever since, right? But what does that actually mean for the shape and the sheer scale of everything around us? So grab your mental spacesuits because we're going for a ride.
So let's start with a really brain-breaking question. If the universe is expanding, shouldn't there be some kind of cosmic wall where everything just stops? Like, think about blowing up a balloon. It expands, sure, but it has that outer rubber layer. So it's totally natural to ask if the cosmos has a border where space simply ends and, well, absolute nothingness begins. And as it turns out, there kinda is an edge, but absolutely not in the way you might think.
Here's the deal. Because light has a strict universal speed limit, and the universe itself is roughly 14 billion years old, we can only see the parts of the cosmos whose light has actually had enough time to reach us. Now you'd naturally think, okay, so the edge is 14 billion light years away. But remember, the universe has been constantly expanding that whole time. So the absolute most faraway things we can see, they're actually about 45 billion light years away right now. That means our personal observable bubble has a radius of 45 billion light years, and that traps around 200 billion galaxies inside it.
But here is the absolutely crucial point. This boundary, it isn't a physical wall where space just runs out. Not at all. Instead, it's literally an edge in time. When we look that far outwards in any direction, we are looking so incredibly deeply into the past that there is simply no past left to see. The universe definitely keeps going past that point for sure, but the light from anything beyond that invisible line just hasn't had enough time to hit our telescopes yet.
And that brings us to a massive cosmic crossroads. Beyond that observable edge, the real universe is definitely bigger, but how much bigger? We're basically looking at two mind-bending options for the true scale of the cosmos. Either the universe is unimaginably huge but ultimately finite, or it is truly, absolutely infinite. And honestly, both possibilities have some wildly fascinating implications. Okay, let's dive into option one first, a finite universe. This essentially means that theoretically speaking, you could fill the entire cosmos with ice cream. I mean, you'd need a ridiculous, astronomically huge amount of ice cream, obviously. But the point is, it would be a measurable finite volume. It has a set amount of space.
But wait, that immediately creates a paradox, doesn't it? If the universe is finite, shouldn't there be an edge, like a physical cosmic wall? And if there is a wall, what the heck sits outside that edge, if the universe is, by its very definition, literally all there is? Like, does the phrase outside of everything even make any logical sense?
To solve this little headache, physics offers a pretty brilliant hack called a hypersphere. Okay, imagine a really tiny ant walking on an orange. The ant can only see a tiny patch of the skin, kind of like how we can only see our observable chunk of the universe. But if that ant just starts walking in a straight line, it'll eventually loop all the way around the orange and end up right back where it started. The surface area of the orange is completely finite. You could paint the whole thing with a specific amount of paint, but it has absolutely zero borders or walls. In a hypersphere universe, our entire 3D space works exactly like that 2D orange peel.
So you're probably wondering, how exactly does space manage to curl back on itself? Well, pulling back the curtain on how our universe operates, it all boils down to gravity. Every single bit of mass creates gravity by bending space-time. This tension stretches out, and the combined gravity of all the mass in the cosmos creates this mild, continuous tension in the fabric of space-time itself. And it's that tension that gently curls the entire universe back onto itself, perfectly closing the loop.
Now, to our human perspective, the universe looks totally, completely flat. Scientists have even actively searched for a cosmic horizon or some kind of optical illusion that would give away the curvature of this cosmic sphere, but they haven't spotted a thing yet. Which means if we really do live in a hypersphere, it has to be so incredibly vast that it appears perfectly flat to us locally. Actually, calculations show it would have to be at least 1,000 times larger than our already massive 45 billion light-year bubble.
But wait, it actually gets weirder. Some scientists have proposed an even wilder, way more complex shape. What if the entire universe is folded into the geometry of a cosmic hyperdonut? I'm serious. In this model, our observable bubble might only make up, say, a tiny 5% of the total structure. That leaves 95% of this massive cosmic donut completely hidden from us. Just like the hypersphere, flying in a straight line would eventually loop you right back to your starting point, but with some incredibly fun geometric quirks. Here's what makes the hyperdonut so trippy.
Unlike a uniform hypersphere where everything is totally symmetric, a hyperdonut universe has an uneven geometry. If two spaceships flew off in different directions, one could literally lap the universe and get back to the start way earlier than the other. And even crazier, this shape would warp light in this bizarre cosmic Hall of Mirrors effect. Because light would take different amounts of time to travel around the donut, depending on the direction, you could theoretically look up, see a star die right in front of you, and then see that exact same star being born on the completely opposite side of the sky.
All right, let's shift gears to the second major option and see how this ramps up our existential awe. What if the universe isn't a sphere or a donut, but is just truly infinite? Interestingly enough, the standard cosmological model that most scientists use actually predicts an infinite universe. We're talking a universe with absolutely no borders whatsoever, where wherever you look, you just find more and more stuff, forever. But hold on a second. We know from the Big Bang that the universe is expanding, right? So if infinity is already literally everywhere, you might be scratching your head wondering how it can possibly get any bigger. The trick here is that cosmic expansion just means the distance between the galaxies is growing over time. You can absolutely take an infinite amount of space and still stretch the gaps between the stuff inside it. Welcome to the brain-bending paradoxes of infinity, folks.
But an infinite universe leads us straight into something truly spectacular. Think about the basic ingredients of our reality. Everything in existence is made from a finite set of particle types. And a finite number of particles can only be combined in a finite number of ways to build things, whether that thing is a rock, a star, a biological cell, or, well, a human. If you have finite options to build things, but an infinite amount of space packed with endless matter, pure mathematical chance dictates that combinations are inevitably going to start repeating.
Because of these finite combinations repeating endlessly by pure chance across an infinite expanse, physics points to a really stunning inevitability. There's an exact copy of you somewhere out there. Seriously, if the universe is truly infinite, there's an exact copy of you sitting on an exact copy of Earth, watching this exact same explainer right now.
Now, before you go planning a family reunion with your cosmic twin, let's look at the numbers. Because the Earth and your exact specific sequence of DNA are so highly improbable, you'd have to travel an unfathomable distance to actually find them. We're talking 10 to the power of 10 to the power of 29 times the size of our entire observable universe. That is literally a 1 followed by 100 octillion zeros.
The sheer mind-numbing absurdity of a number that large means your cosmic twin is effectively forever away. Because these distances are so immense, and because we're completely trapped within the speed of light limits of our observable bubble, these ideas firmly cross over into the realm of science philosophy. As of right now, we just cannot test or prove whether the universe loops like a donut, curves like a sphere, or just stretches endlessly to infinity. And honestly, if it is infinite, we will literally never be able to know for sure. Snapping back to our own reality for a second, what you should really take away from all this is that, functionally speaking, the universe we inhabit is finite. For us, the universe has a strict edge in time. Everything we will ever see, touch, or interact with is safely contained right here within our 45 billion light-year observable bubble. And realistically, that's probably going to stay true forever.
And I think that leaves us with a deeply comforting thought. Even if our accessible chunk of the cosmos is finite, just take a second to think about what it actually contains. 200 billion galaxies, each holding hundreds of billions of stars and planets. It is more than big enough to fulfill all the dreams, the explorations, and the mysteries that we and all of our descendants could ever possibly come up with. It is infinitely enough for all of us.
So, as we wrap up this explainer, I'm going to leave you with a final thought to ponder when you look up at the night sky tonight. Whether space bends back on itself like some giant hyperdonut or stretches out into an endless sea of repeating realities with literal cosmic copies of yourself, isn't the sheer, staggering scale of the reality we can see already magical enough? Thanks so much for joining me on this journey through the cosmos. And hey, never stop wondering about the edge of everything.